close your eyes for just a second. I want you to imagine a breathtaking view of Earth, just floating there in the deep black of space. Now, let's slowly zoom out. We're moving through the atmosphere, past the moon, way out of the solar system, pushing beyond the Milky Way galaxy until you are entirely surrounded by billions upon billions of glowing galaxies. Welcome to this explainer. Today, we're taking a truly cinematic journey into the absolute deepest, darkest mysteries of our universe. We're going to look at the terrifying, unimaginable vastness of the cosmos, and we'll contrast that with humanity's relentless, almost desperate drive to conquer it. It's a story about the fabric of space-time, dying stars, and really the ultimate boundaries of the human mind.
Let's just sit with this unimaginable scale for a moment. 94.5 billion. That's the number of years it would take for a standard spacecraft moving at roughly 28,000 kilometers per hour to reach our closest galactic neighbor, the Andromeda Galaxy. Now, Andromeda is about 2.5 million light-years away. To put that into perspective, even if we magically figured out how to travel at the exact speed of light today, it would still take us 2.5 million years just to get there. It's a pretty humbling reality, right? We live on this beautiful, tiny little rock, entirely surrounded by distances so vast they literally defy human comprehension.
But you have to juxtapose that terrifying cosmic scale with our sheer, stubborn human ingenuity. 30,000. That is the number of massive heat shields, and we're talking each one the size of a football field, constructed for the Icarus mission. In the gripping scenario from our source material, we get this intense vision of human ambition. Our stars fading, Earth is plunging into a brutal new ice age, and humanity just decides to build a colossal spacecraft to drop a massive payload straight into the solar furnace to reignite it. 30,000 shields, that's all that stands between a fragile human crew and the absolute blinding power of a dying sun. So this really sets a profound existential stage for us. Basically, humanity is currently trapped. I mean, sure, we have these incredibly powerful telescopes finding habitable planets out there, but honestly, what is the point if reaching them takes billions of years? We're staring down a timeline where we either just stay grounded and freeze as our stars naturally die out, or we attempt this impossible, eternal journey across an unforgiving void. But what if there was a cheat code? What if instead of traveling through millions of light years, we could somehow just step around them? Well, understanding the actual fabric of our universe holds the key to that escape hatch. Back in 1915, Albert Einstein presented his field equations to the Prussian Academy of Sciences, and these 10 highly complex equations revealed something absolutely mind-blowing. Space is not just an empty, flat vacuum. Actually, scratch that, it's more like a glowing, flexible grid, a space-time mesh. Imagine placing something with immense mass, like a planet or a star, right onto this grid. It physically bends and curves under the weight, and that curvature is exactly what we feel as gravity. And this single, beautiful realization sparked a century of just explosive evolution in astrophysics. Just a year after Einstein's 1915 equations, Carl Schwarzschild mathematically proved the existence of the black hole singularity. Fast forward to 1935, and Einstein, along with Nathan Rosen, found another wild mathematical solution, a bridge. By 1957, that bridge was famously coined a wormhole. And incredibly, as we're going to see, by 2015, we had moved all the way from theoretical chalkboards to actually manipulating physical forces in a lab. So let's talk about that bridge. The Einstein-Rosen bridge is basically our ultimate theoretical escape hatch. The math literally allows for two wildly distant points in space-time to be connected. If we could somehow fold our three-dimensional space through a four-dimensional plane, well, suddenly that 2.5 million year journey to Andromeda could be taken in just a few minutes. We'd essentially be taking that flexible, glowing cosmic grid and folding it over on itself so completely that two faraway points just touch. Now, to really help visualize this mind-bending four-dimensional physics, physicist John Wheeler gave us this brilliant, simple analogy back in 1957. Just imagine an apple. If a little ant wants to get from one side of the apple to the exact opposite side, it has to walk all the way around that curved outer surface. That's exactly like a spacecraft traveling through normal space. But a worm just eats right through the core. It takes a shortcut straight through the center and emerges instantly on the other side. And that is exactly where the name wormhole comes from.
And this perfectly illustrates a really massive misconception. A lot of times when you search for wormholes online, you'll see a drawing of a flat 2D piece of paper folded in half with a pencil poked through it. But space isn't 2D. A real wormhole, kind of like that awe-inspiring one depicted your Saturn in the movie Interstellar, would actually operate from 3D into 4D. So if you were in a spaceship and actually flew up to one, it wouldn't look like a flat tear in the sky. It would look like a glowing spherical crystal ball, beautifully reflecting the distorted galaxies from the other side.
But, and there is a profound catch here, to bend spacetime severely enough to rip open this spherical portal, you need an incomprehensible amount of gravitational force. We're talking the kind of gravity only found in a black hole, an event horizon of absolute no return, where it's so dense that not even light can escape. But think about it. If a black hole is the entrance door, what exactly is the exit? If the other side is just another black hole, well, you're just trapped. The math suggests there has to be an exact opposite. A white hole, a blindingly bright boundary of no admission, where nothing can possibly enter and absolutely everything is violently pushed away. Now, the whole narrative gets even stranger when quantum physics enters the chat. Stephen Hawking famously proposed that black holes aren't entirely black. They eventually evaporate, leaking this faint radiation over billions of years until they just die. But here's the problem. The quantum no-hiding theorem states that information in the universe can never truly be lost. So if a black hole spends its life swallowing up entire planets, stars, and galaxies, where does all that information go when the black hole dies? A lot of scientists theorize it has to be spat back out into the universe somewhere, most likely through one of these white holes. And here is the crazy part. We might have actually seen one. On June 14, 2006, the Neil Gehrels Swift Observatory caught something that should be impossible. They recorded this unbelievably energetic explosion of white light, a gamma-ray burst, designated GRB 060614. Normally, these massive bursts only happen when a black hole swallows a supermassive dying star. But here, there was absolutely zero evidence of any star being present. It was just a colossal eruption of light out of nowhere. This led some researchers to theorize that this was actually humanity's very first glimpse of a white hole erupting in deep space. Okay, while observing the deep cosmos is endlessly fascinating, human ambition definitely doesn't stop at just looking through telescopes. We don't just want to watch the universe, we want to go out there and explore it. So we're pivoting now from grand theoretical astrophysics to the incredible reality of human engineering. Because right now, in laboratories, scientists are actively attempting to construct the actual blueprints for these impossible structures. Case in point, in 2015, a team achieved a truly thrilling breakthrough. Now, while creating a gravitational wormhole obviously requires a literal black hole, they managed to do the next best thing. They created a functional magnetic wormhole. Using a high-temperature superconducting material called yttrium barium copper oxide, submerged in a freezing liquid nitrogen bath, they successfully separated the north and south poles of a magnet. They actually created an invisible gap where a magnetic field entered one end, completely bypassed the 3D space in between, and just emerged from the other side. They built a literal cosmic shortcut right there on a lab table. But what if wormholes prove just too unstable or dangerous to actually traverse? Well, Einstein's equations offer yet another mind-bending workaround. Proposed back in 1994 by theoretical physicist Miguel Alcubierre, the Alcubierre drive is a theoretical engine that doesn't actually propel a ship through space at all. Instead, it moves the space around the ship. By contracting the space-time fabric directly in front of the vessel and simultaneously expanding the fabric behind it, a spacecraft could effectively surf a wave of space-time. You could travel much faster than the speed of light without ever actually breaking the laws of physics. It's brilliant! But let's bring this incredible, futuristic science back down to a deeply human reality. What actually happens to the fragile human mind when it's forced to confront this absolute scale? The immense mystery, the deadly radiation, the extreme isolation of deep space? When you are, say, approaching the orbit of Mercury, staring directly into the unimaginable, violent stale of our dying sun, the sheer vastness of the universe doesn't just bend space-time, it fundamentally bends the human psyche. The crew of the Icarus mission encountered this terrifying darkness firsthand. As they were searching for the lost first ship, the Icarus I, the crew finally managed to breach its airlock. But instead of finding survivors, they were greeted by this wild, overgrown greenhouse that had been completely unattended for years. And as they floated deeper inside, a strange, thick cloud of dust drifted over them in a zero-gravity environment. A quick scan revealed a chilling truth. That dust, it was composed entirely of human skin cells. It was just the lingering, floating ghost of a crew that had simply vanished into the void. They eventually discovered exactly what went wrong. The captain of that first vessel, Pinbacher, had actually reached the sun, but peering directly into its blinding, absolute power just broke his sanity completely, Looking at that cosmic fire, he realized how unbelievably insignificant humanity really is in the grand cosmic order. He concluded that humans were just too tiny, too flawed to play God by trying to reignite a star. His horrifying revelation was a profound philosophical stance. He believed that instead of challenging the rules of life, we should just bow down to the universe's grandeur and accept our natural extinction.
Which brings us right to the ultimate crossroads of our species. The cosmos is unimaginably vast, it's beautifully mysterious, and it is entirely indifferent to our survival. We have the equations, we have the theoretical bridges, the warp drives that might one day allow us to bend the very fabric of reality to our will. But the question remains, will we actually fold space-time to conquer the profound majesty of the stars? Or will we eventually just freeze in the dark, bowing quietly to the universe's natural order?